Inspiring contractors to deliver exceptional craftsmanship with proven results. This is the High Performance HVAC podcast by the National Comfort Institute.
All right, welcome folks to the High Performance HVAC podcast. I'm Casey Contreras. We've got Mark Hunt, Adam Mufich, and the awesome, he really doesn't need introduction, but the great Jim Davis. What's going on, guys?
Hey, Casey.
Howdy.
How you doing?
So let's see, what are we talking about today? CO air-free, air-free CO, CO without air. What is it, Jim?
Well, the air-free part has always bothered me because I went to the gas station once to put air in my tires, and they said it wasn't free. So I kind of gave up on air-free a long time ago. No, it's going back from the early days of combustion, 79 to, I think it was almost 93, 94, before we even had a calculation for it. There's where nobody was doing air-free readings whatsoever till they came out with the smaller handheld analyzers. I don't think any of the expensive ones even did air-free. There wasn't much experience behind it. The other thing that bothered me, we were selling all these carbon monoxide testers, the Pyrite 2 from Backrack, and then UEI came out with one, and all they did was CO. Well, how do you get air free if that's your only reading? Well, you don't. You got to have an oxygen reading or a CO2 reading. And CO2 readings were taken with a bottle. If you're using a bottle, you probably don't know what you're doing anyway. So I don't think air-free would even count. But yeah, then they say, well, the code book says the ANSI standard is 400 air-free for a furnace boiler, 200 air-free for a water heater or an unvented heater. And the worst one is the oven. The air-free on that one's 800. And I can't think of which one would be the most dangerous. Which one are you going to be around when it's making CO and close by? Yeah. Probably why my mom never ate dinner with us at home. She cooked a lot on the stove and the oven. And
Took a nap.
She always had a headache when it was mealtime. I didn't know about CO back then. But there is some confusion on the CO air-free as far as if you're measuring below or before a draft hood, or you're measuring in a flue, that's considered an undiluted sample. Many people have confused that with the air-free sample. Totally different things. Undiluted and air-free, wrong scenario. Undiluted is as measured for us. Just that simple. But Mark, you were reading something yesterday you looked up the other day on CO. That's what? Remember the definition you did?
Yeah, let me here. I'll look at it. CO air-free is a calculated CO concentration that removes the dilution effect of excess air in the flue gases, providing a more accurate measure of actual CO production during combustion. It is always higher than the as-measured CO reading because excess air or unburned oxygen dilutes the flue gas, lowering the apparent CO concentration.
So it says more accurate, but like, what's the point, right? Like,
Now, that's the thing I could never figure out is, and if you've never measured flues in many locations like I have, we show that one picture in the book of taking a combustion test in the flue, a 6-inch flue, and I had 3 readings, 4 inches apart maximum. And the numbers were totally wrong. They didn't agree with each other at all. Now, if you stick your probe in the wrong place, you're going to think, oh, wow, my CO2 or my air-free CO is really bad. But if you move your probe to the right place, you make it go down. So I don't know how. I know they use it. That's what BPI used, isn't it, Mark?
Yeah.
Building Performance Institute. And a lot of obviously your low-income weatherization companies are using it. I don't know that city inspectors really know the difference.
I've never had an inspector ask me anything about combustion.
No.
And as much as I pestered our heating department in Cincinnati, they didn't even want to see a test. They wanted no part of it. They said, well, that's not our responsibility. I couldn't figure out, why would we have an inspector if the safety of the equipment wasn't important?
Typically, the inspectors that I dealt with in all those years, all they did was look at a picture of the venting in the book of manufacturer, the IOM, and look at what I did. And if it looked the same, they said, okay, you're good to go. And that was it. They never checked.
I think the key here is all the definitions say, well, a lot of them say theoretical, but they also say the O2 is not needed. The excess air is not needed. So I think in the oldest article, which you guys didn't see, but it showed that we had something sitting at 7% oxygen. The CO was 95. The air free was 100 and something,
Mm-hmm.
or somewhere. But then I closed the air shutter. I just closed the air shutter down. The oxygen dropped to 6. The CO jumped to like 1,800 parts per million. I said, how can you say that oxygen wasn't needed? And in that article, I was trying to explain how people changing things like that are just screwing up, not getting it right, but they're screwing up the efficiency also. Because if you're trying to tune something to 25 parts per million or 50 parts per million air free, you're going to have a lot of under-fired equipment. But everybody says that's okay. Yeah, you're not paying my gas bill. So there's always been a confusion there. It still is, always will be, I guess. But I don't know that we're going to, that's the least of our problems. Just as long as our people know. If you want to get the right answer, we use the as measured. And again, a lot of analyzers today, what's the number one part that goes bad on an analyzer?
The printer.
The O2, the oxygen.
Yeah.
So when you don't have an oxygen reading, now I know a couple of meters don't even run when it goes bad, but on all the other ones, they'll still measure O2 or they'll measure CO and temperature. So you don't have the ability to even calculate air free.
Right.
So how do you determine if you got it or not? Well, you don't. You ignore it. You use your as measured. Oh, I've got 90 parts per million as measured. That's got to be really high. Well, still under 100. And I think we've got enough slop in our numbers. The industry standard for a furnace is 400 air free. We're stopping at 100 as measured, which of the numbers we have in oxygens, which is 6 to 9,
Mm-hmm.
the CO is going to be less than 200 air free, no matter what. So we're way ahead of the game when it comes to safety of the equipment. And is it how much it is making sometimes, or where is it going? And if it's rising, it's going in the wrong place.
Right. most of the guys at the classes, they don't, never even heard of CO air free, much less knows what it is. And like I said, I don't know, Casey, how you do it, but I just say, listen, the only reason you need to concern yourself at all with this is if you're going to red tag and shut down a piece of equipment, you got to have an authority having jurisdiction backing you up. And that ANSI Z21 standard, that's your authority. But other than that, everything goes through our as measured readings. I don't touch the air free.
Yeah, that's the only thing I touch air free on is just you have that third party to back them up. But I also tell them too, just because that's a industry standard doesn't mean it's necessarily your standard. So they can make their own standards based on what they want to do and what they deem as safe as well, as far as getting under that measurement.
Yeah, that's a good point.
Because I know a lot of our guys, they come up with their own standards. If it's not under 100, they're going to disable and red tag because that's their company policy. Other guys, they don't even pay attention to that 400 parts per million.
And then you could also get people out there that would leave a piece of equipment in operation as long as, if it's 400 parts per million air free, well, it's good to go and walk out. And we know that if it's at 400 air free, I know I'm well over 100 parts per million as measured.
Yeah, exactly.
So, that could be confusing if you tell them, and we sort of do. And it does say in the manual that a piece of equipment, furnace or boiler that is below 400 parts per million air free is within industry standards.
Mm-hmm.
Right?
Yep.
Tank type water heaters are 200, as are unvented. I love that, unvented.
So can a company get in trouble if they red tag a piece of equipment if it's below that ANSI Z21 standard?
I don't know about getting in trouble.
Yeah.
The homeowner could probably challenge them, by what authority are you shutting my heat off? You could get into some sketchy water there.
Yeah.
But as far as like trouble, I don't see how.
Well, that's where we bring in the wanton endangerment part. It says anytime you walk away from something that's potentially hazardous and the people get injured, you can be charged with wanton endangerment.
Yeah.
So
when Dominic and I were at that carbon monoxide conference last year, there was a lawyer there who gave away books, and the guys, it's the brain injury law group. All they do is their clientele is exclusively carbon monoxide poisoning survivors. And I read a paragraph out of that book at the beginning of all of my classes where basically the lawyer is just saying, if there's carbon monoxide in the house, because there's not supposed to be any, somebody's at fault and needs to be held accountable, saying, I'll come and sue your butt. I tell the guys in the class, if you walk by a water heater and you see the grommets on top of the water heater melted and you just walk out of that house, I could buy, a lawyer knows what the Wanton Act is, right? That's what they get paid to do. And somebody gets sick in that house and it's like, you were here last. Didn't you see these melted grommets? I mean, you can try and lie your way out of it, I guess, but, that Wanton Act is something that they need to be mindful of. There are lawyers out there looking for a reason.
Oh yeah.
Oh yeah.
I think I read somewhere that there's a lawyer that specializes in. That's his whole practice, is taking care of lawsuits for poisonings. Yeah,
that's what this guy is. Gordon, I forget what his last name is, but I have the book in my backpack. And that's all they do. They just look for survivors of CO. They're not going after, cases where people died. They're going after representing people who got some kind of physical damage, brain injuries or whatever. I had a guy in a class a few months ago. He got hit with over 3,000 parts per million while he was servicing a furnace. And when he called back to the office to tell him what happened, the service manager told him to sit in a truck for 45 minutes That was the cure, I guess. But I had the guy sit in the class. I said, if you go to page 25 in the course manual, there we got all the lists of all those symptoms of all the potential problems caused by carbon monoxide exposure. I said, I want you to check off every one of the symptoms that you've had since that happened. And he checked off 21 of them.
Wow.
He ended up going to the hospital, going to the doctor. He had to go to see a neurologist. He got permanent damage.
There was an engineer. I'm trying to think where he's out of. I thought he was out of Michigan, but yeah, the university up there. I can't remember his name, but whatever. One of the articles I'll send you both that you haven't seen is it's got a couple set of readings on it. It shows the initial readings. I make a note of this. 6% O2, 90 parts per million as measured, 126 degrees air, or 126 parts per million air free. Fluid temperature 320, final temperature 133. Okay, this company doesn't like their air free over 100. So they start backing it down. And they end up with 11% oxygen. CO's 12 parts per million as measured, 25 air free. Fluid temperature 260, final temperature 115.
Mm.
Uh-oh.
So they made the furnace safer, didn't they?
Yeah. Yeah.
And that's the problem with people that are measuring air free. They're over diagnosing it as a deadly problem.
Yeah.
And of course, we know the deadliest of problems is rising CO. I don't care if you're making 15 or you're making 1,500. If it's stable, at least the only thing it's killing is birds.
Yeah.
Now, what's going to happen? So if these guys are tuning in to air free, and let's just say for this instance, their fluid drops down to 260, it looks safe. Yeah, it pretty much is safe. But what's the negative effect from them dropping or going up to 11% to drop their CO down that low?
Could be raining in that chimney.
Yeah.
I got video of a water heater, the water just dripping out of the flue pipe. This was because of an excessive draft. The dilution air was so great. It was the flue gas temperature in the flue, or before the draft, it was 500. By the time it went about 3 feet up the pipe, it went down to 240.
Wow.
It was going up the chimney at 240.
Now, believe me, after 40-some years of doing this, I can't realize I hadn't thought of this sooner. And I sent a picture to Mark. I'll let you read it. But I measured the combustion below the draft hood and above the draft hood. Can you read off some of those numbers?
Yeah, hang on a second. I got to open it up on my phone.
Okay.
All right, here we had before O2 was at 8.7, CO 28, CO air free 49. So that's before the draft. And after, O2 was 14.2, CO was 19, and the CO air free was 58. Then on another one, before the draft hood, 8.4 O2, 21 CO, 35 CO air free. And after was 14% oxygen, 14 parts per million CO, and 42 parts per million CO air free.
So that's interesting. How does it go up?
Mm-hmm.
Yeah. The CO went down.
That kind of blew me away. That's basically, I'm thinking to myself, darn it. Why didn't I think of that a long time ago? Just to see. Now, you guys have that opportunity, again, it's the purpose of the test is to discredit air free. It's not a safety issue. It's an accuracy issue.
Yeah.
That to me would be major. If you guys could get a few dozen pieces of equipment with draft hoods measured like that, I'd love to see. I don't think they're all going to do that to the air free reading, but it's kind of scary when I think about it.
Yeah.
But I have to thank Bobby Bevel for running those two tests for us this week. So I called him, and he went out and found two water heaters side by side and sent us the numbers. And Bobby,
What did he have to say about his findings?
he really wasn't being, I don't know, informative or he wasn't looking at anything. He just figured we needed it. He doesn't work that way, so it doesn't matter.
Gotcha.
But I think he sees it, and I think that's something we need to pursue a little bit more, just for the fun of it or the reality of it. Go ahead.
I was just going to say, it's a math problem, right? And apparently the math that they're using doesn't work all the time.
Air-free and efficiency on the analyzers are pretty much equal. They don't mean a thing. So it's nice just to look to see and compare the numbers in your own mind to give you more confidence. So, we're always thinking if there's another way to express something or show something, it's a good thing. And like I said, I can't believe after 45 years, I never thought of this earlier.
I'll have to run these numbers by that formula that you gave me, Jim, for calculating what your air-free number is.
Yeah.
Because it doesn't look right.
I know, but that's what the meter was reading.
Yeah.
That's what I question. Is how's the meter reading those numbers?
Well, if the O2 goes up, the CO air-free has to go down according to that formula.
Yeah.
Right. Now my question is, when it comes to air free, if I measure 10 parts per million in the space, what's my air free reading? It have to be 20 times the number.
Yeah.
That's giving it 1% CO2. People say, well, there's no CO2 in the air. Yes, there is. There's 500 to 900 parts per million of CO2 in our air.
Mm-hmm. Yeah.
So that's not air free either. I just wanted to.
If there was no CO2 in the air, all the plants would die.
That's true.
Unless you give them Brondo, it's got electrolytes. It's what plants crave. There, I got my idiocracy reference.
And I just thought it was really important to address this issue again, because looking at a couple more posts on the internet, I'm thinking stressing air-free is just ridiculous. That's obviously someone who doesn't know what they're doing. Is going by hearsay, much less gas pressure. Podcast or YouTube video I just watched says there's no single measurement and more important than gas pressure. That's the number you need. And, oh, geez, it's just frustrating sometimes. But we'll do the best we can, and like I say, you guys get to carry the torch, and I'm going to keep trying to figure out ways to just add to what we have. Not that I got the ability as much, but the mind don't stop thinking. So that's pretty much what we wanted to talk about. You guys got any questions on the air free?
No, I just did the math using that formula, and that CO air free reading should have gone down to like 2.9
Yeah.
when you had the 14% oxygen, according to that formula, where it's 20 divided by the 20.9 minus whatever your O2 reading is.
Yeah. Yeah, 20.9 minus flue gas O2 divided by 20.9. And was it times your measured CO?
Hang on. It says you got your measured CO times 20 then that math formula, yeah. So whatever your measured CO was. So if I did that, then that CO air free number should have been 150 something.
I don't even know why that's even a math equation that exists. Why would I want to multiply my oxygen or whatever that comes out to a measured CO value?
I think this is a good one. Keep it short and sweet.
Yeah, I like it.
Yeah, I think so.
All right. Thank you, guys. Let's do this again. I think what's the next one, Jim? Combustion air?
I'm trying to think. I think that was one of my choices.
Sounds good to me.
Certainly got enough on that. Be nice. That one really requires some type of pictures, I think. Most of which are in the back of the combustion manual.
Yeah, we can do something, I think. Or at least get
You got the water heater in the hotel where it had the board in front of the grill. We had the garage door that had to be open. We had the 4 water heaters on top of the hotel that every time we docked the black block that drafted on one of them, the one next to it stopped venting.
Yeah.
There's definitely there's 3 stories, but there's probably, I remember I was doing a class in Louisville and went to this apartment complex. The boilers were sitting in a 3-sided room in the courtyard of the hotel building or apartment building.
So it was a triangle room?
Huh?
It was a triangle?
No. But with the garage door open, these heaters were spilling also, even with the door open, and they weren't connected to anything other than themselves. So we couldn't say it was building negative. It was just a fact, drafted interference. But yeah, we'll get into that one.
All right. Sounds good. Well, thank you, everybody. We appreciate it. We will catch you on the next one.
All righty.
All right,
Take
guys.
care, folks.
See ya.
Catch you later.
Bye.